name is Irfan, and today I'm gonna present to you the assignment. So the first part is I have to do the graph, and before that I have to input the value for y is equal to x to the power of 2 plus bx plus c. So on this yellow row I have to input the formula. So they give us the value of x, the value of y, which is x to the power of 2, the value of b, and the value of c. So looking at the first example here, we just input the value here. So x to the power of 2, which is 25, plus bx, b, which is 6, times dx, negative 5, and plus the c, which is 9. And they give us the value of 4. So before I drag it down, I need to make b and c value as absolute cell reference because their value is constant. So whenever I drag it down, the Excel will not adjust the value. And this is the answer. After putting all the formulas here, the next part is I have to display both curves on the same graph using the table of values. So using the y is equal to x to the power of 2 and y is equal to x to the power of 2 plus bx plus c. So from this graph you can see there's a two-line graph here. So the blue one is referring to the y is equal to x to the power of 2, and the orange one is referring to y is equal to x to the power of 2 plus bx plus c. So for number 3, we have to find the numeric discriminant and the numeric solution. So for the formula of the numeric discriminant is b squared minus 4ac. The next part is I have to find the solutions for x1 and x2. So what I need to do for the solution is I have to use the if function. So if function is to check the condition if it's true or false. So for example here, if the discriminant is more than 0, then it will help to check the discriminant is negative or positive. So if it's true, which is more than 0, or which is positive, this part calculates the real solution of the quadratic equation when the discriminant is positive. And yet if it is false, which is negative on the numerical discriminant value, it will help to calculate using the complex solution for the quadratic equation. And you can see here, for the example here, when it's negative, it calculates using the complex solution. So what happens if I change the value of c? You can see here that the numerical discriminant is positive and it calculates using the real solution. So for question 4, in conclusion, x is the y-intercept when x is equal to 0. So when y is equal to x to the power of 2, c is equal to 0. Since there is a plus x in the completed square form, it tells us that the y-intercept has increased. We do not include negative b squared over 4 as an expansion of x plus b divided by 2 to the power of 2 gives us x squared plus bx plus b squared out of 4, which cancel out each other. B divided by 2 in x plus b divided by 2 tells us the x-axis of the midpoint of the graph, which is the minimum point. To find the x-axis of the midpoint, we take x plus b divided by 2 equals 0, which gives us x equals to negative b divided by 2. This indicates the graph shifted horizontally to the left as the x value is negative. Hence, the graph is shifted to the left by b divided by 2 and vertically up by corresponding value of y when x is equal to negative b divided by 2. So for question 5, when the discriminant is more than 0, this indicates that the parabola intersect the x-axis at 2 different points. And when the discriminant is less than 0, this indicates that the parabola doesn't intersect the x-axis and the solution is in complex numbers. And with that, I have come to the end of the presentation. Thank you.